right, so welcome back to another video. In this episode, we are going to look at how we can do pure computations on how we can find the integrand, right, to this particular problem on the board. Look at this problem very well. You can pause the video, solve it, get back to it, and look at it again. Thank you. Right, so let's look at how we can deal with this particular problem. We can see that this problem is qualified to be part of the partial fractions family. Okay, so right, so we have to use the partial fractions over here. So this right here can be separated, or this is equivalent to a. All right, this is equivalent to a over 2x minus 1 plus b over x plus 1. This expression is equivalent to this. Okay, so once we know that this expression is equivalent to this, then what we do, we just have to find the LCM for this, do the necessary algebra, and move on. Okay, so this we can have a into 2, a into x plus 1 plus b into 2x minus 1 plus, that should be equal to what? 5x. Right, so once we have this, we can say that let's a x equals -1, right, to find one of the variables. So if x equals -1, then we have a into -1 plus 1 plus b into 2 into -1 minus 1, and that is equal to 5 into -1. Okay, so this clearly shows that this a section is going to 0. So we have this part b into -2 minus 1, and that is equal to -5. Okay, so this we have -3, b is equal to -5. So we have b to be equal to 5 on 3. So we have the value of b. Let's go ahead and plug x equals half into the equation. So this equation we are using. Okay, so let's x equals half. Okay, so if x equals half, then we can say that a into half plus 1 plus b into 2 into half minus 1, that's equal to 5 into half. Okay, so we have a into 3 on 2 plus, this part goes to 0, so we have 0 here, equals 5 on 2, right? So we can say that 3a on 2 is equal to 5 on 2. So we have 10 is equal to 6a. So we have a is equal to 10 on 6, right? 2 goes here 3, 2 goes here 5. So we have a to be equal to 5 on 3, right? So we have the values of a and b. Very, very nice. Interesting. So now we have the values of a and b. What we do, we substitute into the expression, right, so that we can integrate. Now, so we're going to have integral. Now our a is 5 on 3 into 2x minus 1 plus our b is also 5 on 3 into x plus 1, right? Or the x, right? So this expression, now we can easily integrate, right? So let's look at how we can do it. We can decide to separate them term by term and integrate, or integrate all together. By the way, let's separate them to make our work so easy, right? So from here, we can see that integral 5 on 3 into 2x minus 1 dx plus integral 5 on 3 into x plus 1 dx. All right, so We integrate this, after that, we combine them. Good. So here we can continue from here. So we're going to have the integral 5 on 3 into 2x minus 1 dx. We are considering the first one, right? So with this, let's u equals 2x minus 1. Okay, so we can say that du is equal to dx, right? So we can say that dx is equal to du on 2, right? So let's do substitution here, all right? So we can say that we have 5, integral 5 on 3. Now this is u, right? Times dx is du on 2, right? So let's bring out the constant, which is going to be 5 on 3 integral 1 on u times du on 2, right? So this right here, we're going to have 5. When you bring the half out, it's going to be 5 on 6 integral 1 on u du, right? So this basically, the integral 1 on u du is basically ln u, right? So we know that that is integral 5 on 6 ln u. Then we know that our u is right here to be 2x minus 1. So we say that this is basically 5 on 6 ln into 2x minus 1 right here. So we have our first integrand. So let's go and do the second part and sum them. So now we consider this part also 5 on 3 into x plus 1 dx. So here also, let u equals x plus 1. So we have du is equal to dx. All right, so we do substitution, then we have 5 on 3. This is u times dx is du, right? So bring the 5 on 3 out. We have 1 on u du, right? We know that the integral 1 on u du is respectively ln u, right? So we're going to have 5 on 3 ln u, right? But we said that u should be equal to x plus 1, right? So we're going to have 5 on 3 ln x plus 1, right? So once we have this information and we have this information, we can combine them and have the integral for this particular problem. So amazing, right? So we have right here 5 on 6 ln into 2x minus 1 plus 5 on 3 ln into x plus 1 plus our constant of integration. And this becomes the final answer to this particular problem. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates. Bye-bye.